Welcome back, students. In this video, we are going to prove these three trigonometric identities. Example 1. Prove that 3 minus 4 sine square theta, sec square theta minus 4 tan square theta equals to 3 minus tan square theta, 1 minus 4 sine square theta. We are going to prove this identity starting from left hand side. This is the left hand side part. Now, the first bracket copied as it is, and in the second bracket, both the ratios are expressed in terms of sine and cos. So, this sec square theta is replaced by 1 by cos square theta, and this tan square theta is replaced by sine square theta divided by cos square theta, because we have tan square theta equals to sine square theta by cos square theta. Now again, the first bracket copied as it is, and in the second bracket, we are going to take LCM. Here LCM is cos square theta. Since both the denominators, both the term has denominator cos square theta, which is same as the LCM here, we don't need to multiply the numerator. We can directly write it as 1 minus 4 sine square theta. Now let's say this algebraic simplification. If we have b multiplied by a upon c, we can also write it as b by c multiplied to a. That is, we can shift c to the b. The same simplification, we are going to use it here also. This denominator cos square theta, we are going to shift it in the first bracket, that is 3 minus 4 sine square theta and whole divided by cos square theta. Now in the second bracket, it is 1 minus 4 sine square theta left over. Now the first bracket, we are going to split the denominator here. This cos square theta is taken by 3 as well as 4 sine square theta when we split the two terms in the numerator. And the second bracket as it is, no changes. Then in the first bracket, 3 it is here, 1 by cos square theta is sec square theta, and 4 is here, sine square theta by cos square theta, it is tan square theta. The second bracket copied as it is. Once again, I repeat, in this first bracket, 3 is here and 1 by cos square theta is expressed as sec square theta, and the second term of this bracket, sine square theta by cos square theta is expressed as tan square theta, and second bracket copied as it is. Now let's compare this result with the right hand side. This 1 minus 4 sine square theta is present there in right hand side. So we have this result. And while comparing the first bracket, right hand side bracket consists of only tan square theta. So we are going to convert this sec square theta into tan square theta to get right hand side. So in this bracket, we are working 3 copied, and this sec square theta is expressed as 1 plus tan square theta. The formula for sec square theta is 1 plus tan square theta. Remaining parts copied same there. That is minus 4 tan square theta, minus 4 tan square theta, and the second bracket is also same. Now the simplification only is left over. This bracket is opened by multiplying by 3. 3 ones are 3 and 3 tan square theta is here. The rest of the thing is same. Now on simplification, we have 3 minus tan square theta. This 3 tan square theta and minus 4 tan square theta get subtracted, and the second bracket same, which is right hand side. Hence, this identity is proved. Example 2, prove that 1 by 1 minus cot beta plus 1 by 1 minus tan beta equals to 1. Here, complicated portion is left hand side. So let's start from left hand side. in the step here, the numerator copied as it is, and in the denominator portion, the cot beta is replaced by its formula cos beta upon sin beta. Also, in the second term, the numerator copied as it is, and in the denominator portion, this tan beta is replaced by its formula sin beta upon cos beta. Next step, numerator again copied as it is. In the denominator portion, we take LCM. In the denominator, we have two terms here again, and the sin beta is LCM and 1 is multiplied to sin beta. And in the second term also, the numerator 1 copied as it is. In the denominator portion, we take LCM here. Cos beta is the LCM and 1 is multiplied with cos beta minus this sin beta. After this, let's see simplification of an algebraic expression. If we have this type of expression, we say 1 is in the numerator and the x by y is in the denominator. The separator of numerator and denominator is this line, which is next to the equals to sign. These types of expression is simplified as this one. That is, we make equal steps in the numerator and the denominator. Denominator, there is x by y. Numerator also, we divide 1 by 1 so that there are 2 steps in the numerator and 2 in the denominator. After that, we copy numerator as it is 1 by 1 and denominator will become multiplied. The denominator will transform to multiplication with the reciprocal, with its reciprocal. That is, y goes up and x is in the bottom line, that is in the denominator again. And when we multiply, we have y by x. The same simplification we are going to do in this line also. Here, 1 by x by y, the result is y by x. It seems y goes up to numerator to multiply. Here also, this sin beta will goes up to the numerator to multiply it with 1. So, its result is sin beta will divided by sin beta minus cos beta. Again, in the second term also, the cos beta will goes up to the numerator to multiply it with 1 and the denominator cos beta minus sin beta. Again, let's see one more algebraic simplification. If we have b minus a, when we take minus common, the plus b becomes minus b and minus a becomes plus a when we take minus common. And then after arranging it, we have minus, it is inside here a minus b. Similarly, if we have cos beta minus sin beta, and if we take minus common, this cos beta will become minus cos beta. And this minus will become plus after taking minus common here. Sin beta, it is here. Now we have sin beta minus cos beta inside the bracket after arranging. So we have value of cos beta, expressions of cos beta minus sin beta can also be written as minus sin beta minus cos beta. Same here, the first term copied as it is, and in the second term, in the denominator, we take minus common. In this denominator, only we take minus common. Cos beta will become minus as shown in this part. So we shift it to the last portion, and sin beta becomes positive and we shift it in the front. Now, in the next step, this plus and minus will get multiplied. So we have minus here. Plus into minus is minus here. So let's take LCM. LCM is same in both of the terms here. So we have sine beta minus cos beta LCM, and upper portion also we have sine beta minus cos beta. Now, if we cancel plus a and minus a like this, we have 0 answer. They get cancelled and 0 is the answer. But if we cancel numerator and denominator, our answer is 1. So here numerator and denominator are exactly same. We can cancel it, numerator and denominator. So we have answer is 1, which is right hand side. Hence the given identity is proved. Example 3. Prove that tan beta by 1 minus cot beta plus cot beta by 1 minus tan beta equals to cosec beta sec beta plus 1. In this sum, we are going to start from left hand side. Here it is. In this step, all the ratios are converted to sine and cos. So the tan beta is replaced by its formula sine beta upon cos beta, and this cot beta is also replaced by its formula cos beta by sine beta. In the second term also we do the same thing. All the ratios are converted to sine and cos. This cot beta is replaced by its formula cos beta upon sine beta, and this tan beta is also replaced by its formula sine beta by cos beta. Moving on to another step, the numerator copied as it is sine beta upon cos beta, and in the denominator portion we do LCM here. This denominator portion we have sine beta as LCM, and 1 is multiplied with sine beta and cos beta here. In the second term also, we do the same procedure. That is, numerator we copy as it is, cos beta by sine beta, and in the denominator, we do LCM. We take LCM, cos beta is the LCM here, and 1 is multiplied with cos beta, and next is minus sine beta. After this, we simplify it. Sine beta by cos beta, and this denominator portion will become its reciprocal to get multiplied with sine beta by cos beta. The second term also cos beta by sine beta here, and denominator will become its reciprocal to multiply with cos beta upon sine beta. The first term now, sine beta and sine beta, it is sine square beta, and cos beta will multiply to sine beta minus cos beta. In the second term also, cos beta and cos beta multiply to become cos square beta, and in the denominator here sine beta multiplied to bracket cos beta minus sine beta. When we observe the denominator here, inside the bracket, sine beta and cos beta, in both the terms they are same, but they are opposite in sign. Here sine beta is positive and here sine beta is negative. Similarly, cos beta is negative here and cos beta is positive here. In this case, we take minus sign common. Let's see in this small portion, if we have sine beta, cos beta minus sine beta, the denominator portion I have rewritten it here. Sine beta, cos beta minus sine beta. I am taking minus common from this bracket here. So sine beta is here. Inside the bracket only I am working here. Here minus is taken common. So cos beta becomes minus cos beta and minus sine beta becomes plus sine beta. Now when we multiply, okay, first of all let's arrange it. Arranging it, we have sine beta in the front part because it is positive. It is convenient to write the positive part first, and minus cos beta, it is in the second part. Then we have minus into sine beta is minus sine beta. In this way, we can take minus common. So we have sine beta minus sine beta, bracket here, sine beta minus cos beta. This portion we have simplified in this manner. Now, the first term of this part copied as it is. In the second part, only in the denominator, we have taken minus sign common and we have minus sine beta minus cos beta. Look here. Here it was, before taking minus common, it was sine beta, cos beta minus sine beta. After taking minus common, minus will take its place in front of sine beta here, minus common, and this cos beta will become minus. So minus cos beta, this sine beta becomes plus positive. So it is here in the front part, it is sine beta. Now this first part as it is, in the second part plus and minus will get multiplied. It becomes minus here. And now the LCM portion is, we have sine beta, cos beta and sine beta minus cos beta. LCM is here. These two are common, so we have kept only ones, and cos beta and sine beta has no common, so they will stay here. And to multiply with this sine square beta, we have this sine beta. Sine square beta is multiplied by sine beta. Here in the second term, this cos square beta is multiplied by cos beta. Comparing the LCM and the denominator here, sine beta bracket, sine beta minus cos beta is present here, and this cos beta is not there in the denominator. So cos square beta must be multiplied by this cos beta. Now we have in the numerator sine cube beta minus cos cube beta. Using the formula of a cube minus b cube, we have sine beta minus cos beta, sine square beta plus sine beta cos beta and cos square beta. In this step, we use the formula for sine cube beta minus cos cube beta, and it is in the form of a cube minus b cube. So we have used the formula of a cube minus b cube. Now we can cancel sine beta minus cos beta from the numerator and the same sine beta minus cos beta in the denominator. Now in the numerator part, we have sine square beta and cos square beta. These two, sine square beta and cos square beta, this is 1. These two becomes 1, and sine beta cos beta as it is copied, and denominator, the leftover portion is cos beta sine beta, so it is here. Now let's split. While splitting the terms of the numerator, one will take whole part of LCM, that is cos beta sine beta, and also second term cos beta sine beta will also take the whole part of LCM, that is cos beta sine beta. The first part is as it is, but in the second part we can cancel up and down, cos beta sine beta and cos beta and sine beta. So the first term can be written as 1 by cos beta multiplied to 1 by sine beta. The second portion after cancellation we have 1. So this is equals to sine beta is cosec beta, 1 by cos beta is sec beta plus 1, which is the right hand side. Hence we have proved this example also. Okay students, if you want to learn more solutions of the trigonometric identities, you can watch the next video. This much for now. Thank you.